Video 20.1b. Look, I got smart and found a little tripod for my phone to sit on. It's balanced on top of a stack of books, that's balanced on top of a clipboard, that's balanced on top of an open drawer in my desk, so we'll see how long it stays up. But at least it's not shaking around. Okay, so this is just a cartoon image of another galvanic cell. This one is with silver and copper. In this case, silver's getting reduced and copper's getting oxidized. That's different from the last example where copper was getting reduced. So that just has to do with the ability of different metals to get oxidized or reduced. If you remember that activity series that we used way back in chapter 6, that allowed us to predict which metal would get reduced and which would get oxidized. And so it just happens that silver is easier to reduce than copper is, so silver gets reduced. Now we call the electrode at which the reduction happens the cathode. It's always called the cathode. It's got a positive charge on the cathode because we are taking these silver ions and they're being attracted to the cathode, and so since it's surrounded by positive ions, it gives it a positive charge. The anode is always where oxidation takes place. In this case, it's the copper. Copper metals being oxidized into copper ions. So the copper electrode in this case is actually going to be dissolving away. The salt bridge allows ions to flow through to keep these two solutions electrically neutral. And the electrons always flow through the wire. And they always flow from the anode to the cathode every time. So the anode has a negative charge because it's surrounded by negatively charged ions.